I think you're probably aware that we have a problem with mathematics education in this country. We have had for 10 or 15 years or even longer. For those that teach units at university level that need a bit of maths, we have a problem. Talk about some calculators today and also software that's found on every PC. Definition of numeracy, work with numbers. UTS last year introduced a first unit where everyone has to do maths, but they said it was the first, or at least the Australian did, but Bond actually was first. Back in '89, we had a unit where everybody had to do a mathematics subject. Linda Galligan at USQ is on top of this material. Maths A at school is a problem because the students don't do any algebra, and it's not very good as preparation for university work. In fact, the students don't really get an idea of what maths even is until they get to university, many of them. I'm teaching a unit called Elementary Maths at Bond. Students have to cover a lot of material in 12 weeks. As you can see on the slide, I think my slide's a bit too long, more than 20 seconds. The students fail to develop these skills in this short 12-week period. The material that we cover is kind of 1 or 2 years of high school maths, and it's very difficult to cover this material in that time. The calculators, they have problems driving their calculators. Some of them push a lot of buttons on the calculators, they're not sure of what they're doing, and the answer comes out, and they really are very uncritical of that. Calculators also have another problem, that you cannot create a little mathematical model, which I'll talk about a little bit later. So how do we fix this problem with calculators? Well, here's an example of a problem. What is 2 plus 3 times 4? If you read it left to right, the answer is going to be 20. But if you do it properly, 3 times 4 should be done first, and the answer will be 14. And this acronym, BEDMAS, the students learn at school, brackets, exponentials, multiplication, and so on, gives the order of operations. Here's another example. Students in my class last semester evaluated -5 squared. They get -25 from their calculator. So they're not using, I'm pretty sure the calculator's working right, but they're not using their calculator properly. So there's all kinds of issues here, even with simple arithmetic. So I think Ron is going to go around and give you one of these things in a moment, or he already has. You've got a calculator there, it's called QAMA. A fellow in New York invented it. He's a Jew, and it's Hebrew for how much, and it also means quick approximate mental arithmetic. Now, it's a very strange calculator where to use it, you have to give an estimate of the answer before it'll give you the answer at all. So the students are a bit perplexed at this at first, but there's a simple example, 39 times 51. You just round it to 40 times 50 and you get an estimate 2,000. So you type in 2,000 to the calculator and it's happy. Now, there's another one for division. Now, the students are a bit wary of this at first, but when they see their estimates are accepted, they're quite happy. So I spend a little bit of time teaching them how to do simple estimates, nothing too difficult, just rounding to the nearest 10 or nearest 100 normally. Yeah, so that's their reaction. But they're pretty happy once they figure out how it works. It doesn't take very long either, only half an hour. So I discovered this by accident online a few years ago and decided to try it out. They cost $20. My second recommendation to improve the students' mathematical modelling skill was use of Excel. Now, Excel has got tremendous potential for building algebraic skills and modelling skills in the students, yet it's not used very much. But I've published on it fairly recently, and so have a number of others as well. So here are some statements of people who have said about using spreadsheets. I'll let you read those. But it's fairly clear there's a fair amount of research evidence that Excel and tools like Excel do help students with mathematical basics because they force the user to create a model or to understand how a model is working. I'm not talking about accounting spreadsheets necessarily, but little models which show mathematical principles and use of colours, tables, and so on, not necessarily algebra. Of course, algebra is very important, but it augments that. So this lady from the UK has found that spreadsheets are useful in constructing meaning for algebra. Schools seem to be stuck in this graphics calculator rut, which I refer to it as. These machines are okay, but I think we have better ones with tools like Excel. When you graduate from school or university, you find that graphics calculators are not used much in the real world. People use spreadsheets and other computer software. Originally a business tool, but it's used by scientists as well. So I've got colleagues in industry who run workshops for business people and scientists, and he finds that Excel is a common language that they can all understand. So he uses that to illustrate his principles. This is in the electricity marketing industry. University of Sydney has a Centre for the Innovation in Mathematics and Science Education, and this is some of their response to the national curriculum. Spreadsheets are already a numeracy tool of choice for a large part of the population, but the curriculum doesn't use them very much at all. So there's some work to be done there. I set up this journal at Bond about 13, 14 years ago. It's an open access journal for anyone on the planet to publish in this field. We've published 130 or 40 papers, I've lost count, but it's doing quite well. You can also download Excel models which will work in the classroom for you. So I'm fairly outspoken these days. I think we should throw calculators away. We should be looking at better tools. We've got tablets and mobile devices and laptops and so on. We can have spreadsheets or similar tools on this hardware. So I'll end there. Thank you.